All right, hi everybody. Can you hear me okay? Sounds like it. Cool, so in this session we're going to take a deep dive into GraphQL. So my name's Will. I work for a company called Neo4j, which is a graph database. Anyone used Neo4j before? Familiar with it? Okay, a few folks, cool. So I work on a team that builds integrations with Neo4j and other technologies. So I don't work on the core database itself. I work on sort of tooling around the database. And one of the projects I work on is our GraphQL integration, which is what I'm going to talk about today. I also help organize the Missoula Tech meetup and Slack groups. How many people from Missoula do we have today? Cool, great. That's a pretty good number. How many people are already in the Missoula Tech Slack and meetup groups? Cool. Well, if you're not, anyone can join. Even folks from Bozeman. We have a Bozeman channel too. Just Missoula.tech, and there's links to join the Slack group or the meetup group. It's sort of fun, especially for remote workers. It's fun to sort of chat with folks during the day. Cool. So here's kind of what we're going to talk about in the next 40 minutes or so. Sort of an overview of GraphQL, talk about how to build GraphQL services. We'll look at some database integrations for building GraphQL APIs. We'll talk about how you can deploy GraphQL services. Then we'll look at, from the front end, specifically with React, how do we query a GraphQL API? And then we'll take a look at some ways to do authorization with GraphQL. That's a lot to get through. If we don't get through all of it, these slides are online, bit.ly/GraphQL BSDC for Big Sky DevCon. Before we get into that, in our examples, we're going to use Neo4j as our data layer. So I just want to talk a little bit about Neo4j, but a lot of the GraphQL things we'll talk about apply to really any data layer. So like I said, Neo4j is a graph database. What that means is that unlike other databases that use tables or documents as the data model in Neo4j is the graph. So nodes, these are the entities, the objects in the graph, relationships connect them. Specifically, that data model is called the property graph data model because we can store arbitrary key value pair properties on nodes and relationships. Those are the attributes of our data. Neo4j uses a query language called Cypher. There's an example here of Cypher. Cypher you can think of as kind of like SQL, but for graphs. It's all about pattern matching, so we sort of draw these ASCII art representations of a traversal through a graph. So there's lots of interesting things you can do with graph data in a graph database. These are just sort of some of the common use cases that we see people using Neo4j for, things like fraud detection, graph analytics, logistics, graph-based search. But really, I think once you start thinking in terms of graphs, you start to see graph problems everywhere. And because we're talking about GraphQL, I think we'll start to see that there's really sort of a symbiotic relationship when you're using GraphQL, which exposes graphs on the front end, and a graph database with a graph backend. Cool, so that's a little bit about Neo4j. These are the different components we're going to talk about today. GraphQL, React, Apollo, and Neo4j database, or together the grand stack. And there's some starter kits and tutorials that talk about using these technologies together on grandstack.io. Cool, so how many people have written a GraphQL query? Okay, a few folks. How many people have built a GraphQL API? 4. Okay, cool, great. So first of all, what is GraphQL? What are we talking about today? So fundamentally, GraphQL is a specification for a way to build APIs. So you can think of it more as an alternative to REST than as a database query language. So GraphQL is an API query language. To start off with GraphQL, we define the types available. So GraphQL uses strict type definitions that define all of the types, the fields, how those types are connected. And then the client in a GraphQL request is free to query any of that data that it wants. And the data that it gets back is exactly the data that's requested. This is different from REST, which maps to resources, where we say, okay, I want this user object, and I get back all of the user data, right? And then maybe there's a specific reference on the user data, like all of the user's blog posts, and I make another request that says, okay, give me blog posts for this user, right, in multiple requests. With GraphQL, we do that all in one request. So GraphQL makes this observation that your application data is a graph. So if you're talking about customers that make orders, those orders contain products, those products are fulfilled by vendors, right? All of this data is connected, and that's a graph. And this is beneficial because really when we're interacting with an API, we're doing this sort of in the context of relationships, right? Like for this user, give me their blog posts, right? So it's helpful to work with an API in the context of relationships, which is what GraphQL gives you. So let's look at an example. Let's say we have some data about movies and actors, directors, genres, this kind of thing. So the first thing we do is define our type definitions. So here we're defining a movie type that has a title, that's a string, it has the year it was published, that's an integer, and then it can also have fields that reference other types. So a movie belongs in one or more genres. So here we're referencing the genre type, and that's a relationship in our graph. So types, these are the nodes. These fields referencing other types, those are the relationships connecting our types. This is using the GraphQL schema definition language, or SDL, which is this language agnostic way of defining our types in GraphQL. A really useful feature of GraphQL APIs is what's called introspection. So we can ask a GraphQL API to tell us all of the entry points, all of the types, all of the fields, all of the data that is available in that API. And that basically becomes the specification, the documentation for the API, which is really, really handy because that doesn't mean the developer has to maintain this documentation. It's the API itself saying, yes, this is the data I have, this is what you can ask for. And there's lots of nice tooling built on top of this introspection feature. This is a screenshot from a tool called GraphQL Playground. So here we see under queries, these are the entry points for the API, so we can start asking for movies, users, actors, genres, whatever. And then over on the right here, this is for actor. We can see all of the fields available for actor. We can see how we can traverse, in this case, to movie by following this acted in field and so on. Here's mutations. Mutations are sort of the write operations in GraphQL, but also the entry points, the starting point for our API. Here's an example of a GraphQL query. So the components of the query, first of all, we start with an entry point, which maps to one of these fields on the query type. So in this case, we're starting at movie, and we're passing in title as an argument. So we're searching for a movie with a title, A River Runs Through It. And then the rest of our GraphQL query is called the selection set. And in the selection set, we're specifying the fields that we want to be returned, but then also we're specifying how to traverse through the graph from this movie. So we start at the movie node, A River Runs Through It, and we grab, in this case, the title. Then we go to, okay, all of the actors connected to this movie, give me their names, same for genres. Now here when we get to directors, okay, who are the directors of A River Runs Through It? Give me their name, but then also traverse out from those directors to find other movies that those directors are connected to. So this is describing a traversal through a graph, starting at A River Runs Through It. Here's what the response looks like. This is JSON, and this response maps exactly the shape of our GraphQL query. So we're getting exactly the fields that we requested back, and nothing more. nothing less. So, like I said, GraphQL is an API query language, not a database query language. It lacks a lot of semantics for things from like SQL and Cypher, so we can't do projections, aggregations, these kind of things are not built into GraphQL. And GraphQL exposes our data as a graph, but we can really use it with any data layer. So we can even wrap existing REST APIs, we can call out to really any data layer in a GraphQL API, and oftentimes one of the benefits of GraphQL is that we can combine data from multiple sources into one unified GraphQL schema. So what are some of the advantages of GraphQL? Well, GraphQL addresses this problem called overfetching that we see a lot in REST. This is the problem where, okay, if I'm rendering a view in my application, maybe it's something like a list of blog posts and their authors, where I'm just showing maybe a summary. And in REST, because that's mapping to resources, if we request a user object, we get back all of the fields on there, on that user object. But maybe for my view, I just need to display like their name and like their screen name. So with GraphQL, I can say only give me these two fields on the user type. I don't need all this other data. So one, that's less data that's sent over the wire, but also if some of those fields are computationally expensive, if they're part of an expensive database query, I don't need those, then I don't have to go out to the database to fetch those fields. I don't incur that expense. The other problem that GraphQL addresses is underfetching. So going back to this example of a list of blog posts and all of their authors, if I'm rendering this view in my application under REST, I might get back a list of blog posts and maybe I have an ID for the author, but I don't have their name and screen name. So then I need to make a request for each one of those to my API to give me the user information for each one of the authors of that blog post. So I end up making multiple round-trip requests to my REST API. Well, with GraphQL, I can say in one request, this is the data that I want for each author, give me their name and screen name. So I just make one round trip to my API. Another benefit is that GraphQL has a specification, so there are clear distinctions of what makes GraphQL GraphQL. In the REST world, you don't really quite have that similar analog, so you end up arguing and discussing lots of different ways to implement your API. With GraphQL, it's graphs all the way down, so we're working with our data in the context of relationships, how the data is connected. We talked about this a little bit, and it's also useful for taking data from multiple systems and putting them together into one API. And then another benefit is making it easier to componentize data fetching, which we'll see an example when we get to our React example. Okay, so that all sounds great. What are some of the challenges in implementing GraphQL? Well, the one thing here is that a lot of well-understood principles from REST don't really apply in GraphQL. So one example is HTTP status codes. So with GraphQL, first of all, we're making a post request for everything, which doesn't quite translate from what we might be used to. But the other thing here is that we're getting 200 OK response always, regardless of maybe we had some errors for some of our fields. So error handling has to be handled differently. We can't use web caching the same way with GraphQL that we do in REST. Another challenge is exposing arbitrary complexity to the client. If the client is free to select whatever fields and traversal it wants, how do we on the back end make sure that we don't run into performance implications there? Another problem is what's called the N+1 query problem. This is in our GraphQL server implementations where we may be making multiple requests to the database in order to fetch all of the data that we need for our GraphQL query. And then another common challenge is this idea of query costing or rate limiting. if the client is free to sort of construct arbitrarily complex queries, how do I put sort of a rate limit on that? How do I know sort of what the cost of that query is? So these are some of the challenges. There are sort of tooling and best practices that address a lot of these, but I just want to sort of point out that these are some of the things that you think about and that you run into. Okay, so let's look at an example API and how it was built. So this is a screenshot of the Neo4j community site, which is a discourse forum. So if I go to community.neo4j.com, the first thing I see at the top here are some activity feeds. So okay, these are like blog posts about Neo4j, GitHub projects about Neo4j, and I can sort of upvote these depending on how interesting I think they are. And all of the data for this from above the fold is coming from a GraphQL API. It is running at community api.neo4jlabs.com. So let's take a look at that. So first of all, so this is GraphQL Playground. This is kind of like Postman, like an IDE for exploring my GraphQL API in the browser. And the first thing I can do, if I click on schema, I can see, okay, here are all of the entry points for this API. And the first one I see here is top community blogs and content. Okay, that returns an array of community blog objects, which has a title, URL, an author field that's connected to an author type. Okay, so this is going to give me a list of blogs and their author. Okay, cool. So to write our GraphQL query, we start with the entry point, which is top community blogs and content, and then we can specify the fields that we're interested in. So we want, I don't know, title, the URL, and okay, we get back, here are the top blogs currently, and notice I'm just getting back the title and URL, even though there is information about the author, like their name, screen name, avatar. If I add those fields to the query, then when I make the request, okay, I get back those fields, so I can render it in my view. And this is just the API that Discourse loads when we load that page. You can go into the network tab and sort of inspect the request here. It's just making an HTTP request to populate the data here. Cool, so let's talk a little bit about how that API is implemented. There's a blog post that I wrote that goes into more detail here, but we'll talk about the basics. So first of all, the database that this is querying is a Neo4j instance that's running in Neo4j Cloud that we call Community Graph. So we have some Lambda processes that are monitoring like GitHub, Twitter, Meetup, Google for anything related to Neo4j. So if you publish a new Neo4j related project to GitHub, it ends up in Community Graph, and then we can sort of query that to see what the Neo4j community is working on. So that's sort of the data layer for this API. If we query it in the database, it looks kind of like this. So here we're looking for all Neo4j related GitHub repositories that were created by GitHub user Johnny Montana, that's me, and we get back sort of this graph view of the data. But for our activity feeds, we can't just sort of expose our database and make these database queries directly. I mean, you could, but we want a better, more simplified way to do that through GraphQL. So the first thing that we do to build our schema is to start with our type definitions. So here, these are the types that we saw in GraphQL Playground a minute ago. So we have a community blog, what fields are on that, how is it connected to the author type, and then we define an entry point. The query type defines all of the entry points for our API, so every field on the query type becomes an entry point. So here we're defining this top community blogs and content entry point that gives us an array of community blog objects. Cool, so we talked about that, and this this type definition, this is just a string that we're building up. So in this case, we're going to build a Node.js Express app that's going to serve our GraphQL API. So this is just a string. The next bit is to define what are called resolvers. So resolvers are the functions that contain the data fetching logic for our API. So the resolver needs to know, in this case, how to go out to the community graph Neo4j database to query that for the top community blogs. And inside the resolver, this is where we might query a database, we might query another API, we might have our own sort of data access layer that we're calling out to. So there's lots of flexibility here for how we're fetching and resolving data. In this case, we're running a Cypher query. So this Cypher query, this is implementing what's called an exponential time decay function to rank the activity feed. This is the similar thing to what like Hacker News and Reddit use, so that current things that are getting upvoted come to the top and things that don't get voted sort of float away kind of quickly. So here's our resolver. So this resolver is for the top community blogs and content query field. And this is just some boilerplate here. We're just using the Neo4j database driver to make a query to the database, pull out the data that we're interested in. We sort of massage it a little bit to get it into the format we expect. So just kind of boilerplate. And once we have our type definitions and our resolvers, then the next piece is to actually serve this up with a web server. In this case, we're going to use Apollo Server. So Apollo Server is a library built on top of Express in Node that basically allows us to just take our type definitions and our resolvers, and it gives us what's called a executable GraphQL schema. And we can then just pass that executable schema to Apollo Server, and it takes care of serving the GraphQL endpoint using Express. The other thing we need to do here is create a database driver instance, and we make sure to inject that into the context object. So each resolver is passed a context object, which can hold things like database connections, authorization rules, this kind of thing. Cool. And so that's basically the code for this community API that we use to power those activity feeds. This is sort of what I would say is maybe the standard or maybe the naive approach of building a GraphQL API, where you just sort of implement these resolvers that query a database. And you can see there's kind of some common problems here. One is schema duplication. We have a schema for the database, we have a schema for our API. There's a lot of mapping and translation code here in our resolvers. There's a lot of boilerplates. Here's how we send a query with the driver, error checking, this kind of thing. And then also, here's this n+1 query problem that we talked about. So you can see how if our top level resolver returns a list of blog posts, well, maybe we just have an ID for those blog posts, for the blog post author. Now we need to go back to the database and say, okay, I have this blog post, now give me the author information, and that's another round trip to the database, which we'd like to avoid. So there are a class of tooling which are sort of loosely called GraphQL engines that address some of these common problems. Here are some examples. Prisma, AWS AppSync, Hasura, PostGraphFile, and then the Neo4j GraphQL integration. And some of these tools work on top of Postgres or Mongo. AppSync, for example, exposes all of your AWS resources as a GraphQL API, and then the Neo4j GraphQL integration works with Neo4j. But they're largely addressing similar problems, which we'll talk about in a sec here. So let's look at the Neo4j GraphQL integration. So the goals for this integration are to support what's called GraphQL first development, where our GraphQL schema, our type definitions, are sort of driving the API and the database. We want to be able to generate database queries from arbitrary GraphQL requests, and we don't want to have to implement resolvers. And then we also want to have some ability to define custom logic using, in this case, Cypher, because that's the query language our database uses. So GraphQL first development is this idea that everything starts with your type definitions. So in this case, we take your type definitions that the user creates, and we use that to define the database data model. We auto-generate the entry points for your API. So the query and the mutation field, we give you CRUD operations for all of the types that you've defined in your type definitions. And then we also augment the types that you've defined to add things like ordering, pagination, complex filtering. We add in native database datetime types. The filtering is, I think, particularly interesting. So in this example here, we're starting at the movie entry points. We're searching for movies that the plot contains the word zombie, and it's a comedy, and it was released after 1994, or and it has either Jesse Eisenberg or is an animation, right? So we can construct these fairly complex filters, and what's nice is that no matter what arbitrarily complex GraphQL query we have, this still just results in one Cypher query that's generated for one database call. And then if we have custom logic, we can annotate a field in our schema using what are called GraphQL schema directives. And in this case, we're annotating a field sessions by substring. So here we just want to do some sort of fuzzy matching using a Cypher query. And this then becomes a computed field. So rather than just fetching this field from the database, we run this annotated Cypher query as kind of a subquery. So this is really nice for implementing custom logic beyond just simple CRUD. Okay, so these integrations, there are a few different versions of them. This is Neo4j GraphQL.js, which works with all of the JavaScript, so like Node.js GraphQL implementations. There's also a Java version and then a plugin for the database itself. So just sort of a reminder here, we're building an API where our client is not talking directly to the database. Our client is talking to some API server that we're building, and this API server has the logic for generating the database query, fetching data from the database. Cool. So let's look at an example using this Neo4j GraphQL integration. So here we're going to start with a GraphQL schema that has users and businesses and reviews. So a user writes a review, that review reviews a business, that business is in a category. And let's see here. So I have a Neo4j database. This is a tool called Neo4j Browser, which is like a query workbench for Neo4j. So I have a Neo4j database running locally that has this data. So businesses are in a category. User writes a review that's connected to a business. That's kind of the data model we're starting out with. And here's my code. So is that big enough to see? So I'm pulling in our type definitions that we saw in the slides there. I'm pulling in Apollo server and Express, pulling in the Neo4j database driver, pulling in this make augmented schema function from Neo4j GraphQL.js, and pulling in some things to set some environment variables. So I created a new Express app, and then I'm passing in my type definitions. So those are just that big string that we saw on the slide that's defining type user, business, review. And I'm passing that to this make augmented schema function. So this is kind of similar to what we saw before with Apollo server, where we were passing in the type definitions and our manual resolver functions that we wrote. But here, all we're passing in is this string that's defining our types. We're not defining any resolvers, but we get the same sort of executable schema object that we can then pass to Apollo server. So just like before, we're passing in a database driver into the context so that in our auto-generated resolvers, they'll have the ability to call out to Neo4j, and we pass in our schema object. And then we're saying we want to run on /GraphQL and basically start listening on localhost. So let's go ahead and start this. It says, okay, we have a GraphQL API on localhost 4001/GraphQL, which is here. Cool. So the first thing I can do is take a look at the docs here, and I can see, okay, I have my entry points for user and business. So let's search for some businesses here. Let's add a filter where the name contains, I don't know, brew. Let's search for breweries. And let's just give me, I don't know, the name and city of these businesses. Okay, and I've got some breweries in Missoula. I've got a coffee shop in Missoula, Alpha Acid in Belmont. Okay, and I can start to add things like, okay, show me the average stars. Okay, so maybe for my application, I want to order by average stars descending. So I want to show, like, for your search, what are the highest rated first? And what's going on here, if we jump back to our code here and take a look at the debug output, we can see here the Cypher query that's being generated from our GraphQL request. So we're making GraphQL requests, and this is generating a Cypher query to fetch some data out of the database. Okay, that's cool. So that's just doing basic CRUD. But what if we have some more complex logic? What if we want to say, like, I don't know, recommend businesses to users based on their personal preferences? So this is really easy to express in a graph database like Neo4j. It's called collaborative filtering. So if I've reviewed a business, who else has reviewed it? What businesses are they reviewing that I haven't been to? Those might be good recommendations for me. So that's what this query is here. It's on, or here rather, on one long line here. But it's basically just in Cypher saying, starting from this, so here to point out what's going on here, this is a field, recommendations, that's returning a list of businesses on type user. So for any user, I can say, give me the recommendations field, and that's going to give me an array of businesses. These are businesses you might like. And where's the logic for that query coming from? It's coming from this Cypher query that's saying, implement this collaborative filtering algorithm to find businesses you might like based on your reviews and other reviews. And all I've done is just sort of annotate that field with the query. That's defined in my type definitions. I don't have to implement that in the resolver. So let's see if we can use that. So now let's start from the user and let's filter for the user named Will. And let's just make sure we can find Will. Yep, there's Will. And let's search for recommendations. And let's, I don't know, give me the name and the city of the business. Okay, so here's, it has one recommendation for me, which is Hanabi in Burlingame. And I can see, okay, well, what is that? Let's now look at the categories. Okay, this is a ramen restaurant that it's recommending for me that I haven't been to. Well, I have actually been there, but not in the database. And so we can see here, okay, now we're running a slightly more complex query. Our recommendation query, which is this user reviews, that's just getting run as sort of a subquery in this one generated query. So what's cool about this is we're sort of solving some of these problems that we talked about before, where we have multiple round trips to the database, we have a lot of boilerplate code to write, and we're solving that with this sort of database integration. And these GraphQL engines, they're declarative database integrations that take this approach of using your type definitions to drive the database and generating queries, which I think makes it really, really handy for working with GraphQL. One thing that's interesting, so you might wonder, okay, how are these GraphQL engines, how do they have the logic for generating these database queries? Well, the way that they work, if we look at the signature for each resolver is passed some arguments, like the context that we saw that has our database connection. But another object that every resolver is passed is called the resolve info object. And inside the resolve info object, we have lots of information about the GraphQL query. So we have the AST, the abstract syntax tree of the query. We also have the full schema. We have the selection set, so we know what fields the user is requesting. So these integrations basically just take that object and iterate over like the query AST and the schema to generate a database query, which is pretty cool. Okay, cool. So we saw how we can run a GraphQL service locally. We're using Express as a Node.js app. How do we deploy these things? Well, there's lots of options here. I mean, we can deploy, in this case, our GraphQL API any way that we might deploy a standard Node app using platform as a service, like on Heroku, Elastic Beanstalk. We can put it in a Docker container. We can spin up our own server, install it on that. What I think is interesting and gives you a much more simplified developer surface are serverless options. So these are things like AWS Lambda, Google Cloud Functions, Azure Functions, where we can basically map a handler for a request to the GraphQL endpoint. And that's nice. And there are even tools built on top of Lambda, Google Cloud, like Serverless Framework, or ZiteNow, or Netlify, that basically give us really, really nice developer tooling that takes care of packaging up our code and sort of shipping it to AWS or GCP and creating a cloud function for us. So, for example, if I want to deploy my GraphQL API that I wrote onto ZiteNow as a sort of serverless function, I just type now and it says, hey, do you want to use your package JSON definition or Dockerfile? I also have a Dockerfile example here, and I can say, hey, I want to use package JSON, and it says, oh, well, I already deployed that for you. Here you go. Here's the endpoint, and it takes care of sort of mapping that to a Lambda function for me, which is quite nice. Cool. So those are some options. There's some resources linked in the slides here. So taking a look at sort of the full stack angle here, the other components that we're talking about. So we talked about GraphQL. We talked about Apollo server. We talked about Neo4j. What we haven't talked about is the front end piece here. So we saw that we could query GraphQL with GraphQL Playground. That was nice. But let's talk about, okay, we're building an application, maybe we're using React. How does that work in the context of GraphQL? So there are lots of GraphQL clients out there. We're going to take a look at Apollo client, which I think is the most popular GraphQL client currently. There are Apollo client integrations with lots of different front-end frameworks. We'll look at the React example. And then there are lots of other alternatives, things like Relay from Facebook, Urkel, which is another GraphQL integration. The example that I showed for that discourse activity feeds, the Neo4j community site, that's just making a fetch request, HTTP request. So it sort of depends on your requirements. The nice thing about Apollo client is the front-end framework integrations, and also implements a client-side cache, which is nice. So here's a React app. How do we use Apollo client? Well, the first thing we do is create an Apollo client instance. We pass in a URI for our GraphQL endpoint, and then we need to inject that client into our React component hierarchy. In this case, we wrap our app component with Apollo provider. This is similar to like the context API. If you use Redux, it's kind of a similar pattern there. And then here is the render function for, let's say we're rendering like a table. And we have a query component now where we can, as props, pass in a GraphQL query, any parameters for that query, and then we have the logic for handling the response to that query. In this case, we take the data and we render a table. Cool, so the nice thing about the React integration here is that we talked earlier about sort of compartmentalizing our data fetching with GraphQL. So here we're basically taking a GraphQL query and we're saying this query defines the data fetching logic for this component, which is really nice for sort of encapsulating that logic. Cool. So we'll skip sort of the front end demo in the interest of time here, and we'll sort of gloss over our authorization options, which I wanted to talk a little bit about. Basically, with authorization, there's lots of different ways to implement authorization in GraphQL, from sort of naive approaches of like just checking some authorization token inside a resolver that's passed through the context object, to things like GraphQL middleware that wrap our resolvers. An approach that I think is particularly interesting is this idea of using schema directives to implement authorization. So we saw the Cypher schema directive earlier where we were sort of annotating fields. We can use the same approach for authorization where we're annotating fields and types with authorization rules. And there are some packages out there that expose these authorization rules as schema directives. Cool, so I'm a bit out of time here, but I want to mention a few resources before we end. So first of all, I want to point out that we were looking at Node.js JavaScript code for building our GraphQL API, but I want to point out there are GraphQL implementations in lots of different languages, Java, Python, Ruby, .NET. So we're not just talking about building JavaScript APIs. There's lots of good blogs out there, documentation. GraphQL.org is sort of the official GraphQL documentation, but there are some other resources as well. All of the sort of code and the Neo4j GraphQL integration that I talked about is part of GrandStack. There's a GrandStack starter if you go to grandstack.io that has very similar code to the demo that I was working with. It shows you how to spin up both the back end and the front end. So there's sort of a deep dive on authorization. And then finally, if you're interested in Neo4j, Neo4jsandbox.com is sort of a great way to get started there. It allows you to spin up a Neo4j instance sort of private to you with data already loaded. Cool, so we have 1 minute left, so maybe we can take one question if anyone has one. Yeah?
So I see that you're using Neo4j for database, and a lot of places have more traditional databases like Oracle, Microsoft SQL Server, MySQL. Is there anything that can allow you to use GraphQL with
Yeah. Yeah, so the question was, okay, you showed us that Neo4j integration, that looked cool, but I'm not using Neo4j, I'm using Oracle, Postgres, MySQL, whatever. Is there tooling that lets me use GraphQL with my existing database? And the answer is yes, there's a lot out there. Specifically for these sort of database integrations, the GraphQL engines that we talked about. These are some of the top ones. Prisma, for example, works with Postgres, MySQL, Mongo. They're working on an Oracle integration. Hasura and PostGraphFile work with Postgres. There's another project called Join Monster, which generates generic SQL and different flavors of SQL as well. So yeah, there's lots of different tooling. They don't all have the same features. That sort of schema directive for custom logic thing that we looked at, that's kind of specific to Neo4j GraphQL, but yeah, there's lots of tooling out there. Cool. Well, thanks everyone. I'm out of time. I think it is lunchtime now, but if you have any questions, I'll be here. Feel free to chat with me. And thank you.
I